Okay. See, Young's modulus. I'll tell you about Young's modulus today. Okay. Just a minute. Young's modulus of elasticity. Okay. You know what? If you are standing here, okay, and I apply force on you, okay, then you will resist. You will resist. I don't know whether it is correct spelling or not, but you will resist, and basically you are going to apply an equal and opposite force to the external force. Okay, this is called as reaction force, or you can call it as internal force. This is the external force which I am applying on you. And this is the internal force which your head will apply against the external force in order to keep the head in its position. If you don't apply any internal force, then obviously your head will come out, or not your head, but somebody head, or who is actually, if you are not doing anything also, it's already, the neck is there, the neck. Anyway, some things are there which are joining something else, and because of which it will not come out just like that, because there is, they have to break out, right? So basically you are going to apply some, anyone, not only you, means that material, whichever is the material, that will apply some resistance force. Automatically it will come into picture, even living thing or non-living thing. It's not about living thing. Even non-living thing also, if you stretch something, na, I'll tell you one example. For example, your book is there, na, your book. Suppose you are stretching it like this. What the book will do, you know? The book applies equal and opposite force in the reverse direction, means equal and opposite force, so that it does not get stretched out. Okay, even the rubber also, when you stretch it now, it will apply some resistance force. Maybe that resistance force is less than what you have, because it has some capacity, it can resist. So maybe your applied force will be more than the resistance force. So all those things are there. So always, whenever you apply an external force, corresponding to that, there arises internal force in that body, which acts against the external force. Do you agree or not? You agree or not? Agree or not? Everywhere it's happening. Everywhere it's happening. Okay. You take anything and you try to apply some force on it. Definitely, it's applying a reverse force in the opposite direction in order to. It's trying to resist. Everything is trying to resist, especially the solids. All the solids will try to resist. Resistance is our life. Okay. We always resist. Okay. Resist. That's the internal force. If you try to compress something, obviously, if it's a solid, it will resist. It will resist and apply some. Automatically, internal force will come into picture. Automatically. How and why internal force will come into picture? So let's go in detail why internal force will come into picture. Obviously, you see, some molecule is here, right? Some molecule. Some molecular atom, whatever you call it. Okay. Now you are trying to pull that molecule, right? So that molecule may be bounded or having some intermolecular force or some kind of force or bond or something with another molecule, right? So there will be another molecule here. If you try to pull out that black molecule, it is already bonded with the blue molecule. So blue molecule will apply it, that there will be some bonding force between them, right? So that since there is a bonding force between them, there will be a force due to that blue molecule. It's already attached with the black molecule with some force. So that will apply resistance force. That is the internal force will automatically come into picture. Understand? That is the intermolecular force basically will come into picture. Okay, understand? So that's that kind of thing. Okay, because of the structure of the body, because of the intermolecular forces in the body, structure of the body, the type of the body it is. If it's a gas, it may not apply that much resistance force. Okay, it will stretch out. But if it's a solid, definitely it will apply some resistance force. Agree or not? Do you agree or not agree? Okay. So I am talking about this internal force. Okay. Even in the real life also, I will tell you one thing example. Even in the spiritual things also, some exam is there. So that's kind of external force. And then you get stressed internally, right? Okay. So something like that. So there is always, for an external thing, we develop an internal thing. Okay. In order to oppose it, in order to handle it. Okay. So one thing you understand that this internal force basically, internal force upon area over which this is acting, area over which it is acting. Now that if that area is very small now, then this ratio will be very big. So that is called as stress. This is called as what you know? Stress. In real life also, we develop stress. Okay. Because of some external force, we will develop some internal force inside our mind. And our mind is very, very small, now, then stress will be very big. And if we think broadly, our stress will be low. So stress is something like internal force upon area over which it is acting. Okay. Suppose this object is like that, this is the area of the object, it's a cuboid kind of object. So we are talking about this area over which the force is acting. The area over which the force is acting. Okay, this area. That's called cross-sectional area. So this is called stress. And because of that, understand, stress is clear to you? Stress is clear. And then I tell you one thing, that if there is a stress, so suppose there is an external force is there, suppose you apply some 10 Newton force, okay, 10 Newton force, then maybe initially the body will not move. And if you go on increasing the force, there will be some force in which the body starts stretching out. The body starts stretching out. And in one position will come, you are still applying 50 Newton, but body has stopped stretching out. Body has stretched out and stopped stretching out now. Okay. This is called as equilibrium position. Which position, you know? Which position, dear students? Equilibrium position. In this position, there is an internal force. Still, there is an internal force, which is reverse direction. 15 Newton. There is an internal force is there. Okay. But both external and internal forces are zero. Therefore, it's in equilibrium position. It is not moving. But anyway, it has elongated by certain length. So how much there is a change in length? Total change in length. Okay. How much there is a change in length, and what is the original length? How much there is a change in length, change in dimension or length, whatever it is, upon original length of the object. This is called a strain. What is this called? It's called what? Strain. S-T-R-A-I-N. Like, okay, now strain. So maybe if you remove this 50 Newton force, the body will regain its original position or original shape. But as of now, there is a strain, and the strain is nothing but change in length upon original length. That is called strain produced in the body. Okay. Now, one thing is there, that the ratio of the stress upon strain, the ratio of what? Stress upon strain, that is a constant for a particular material and a particular temperature. Its value is constant. Its ratio is constant actually. Constant value for a particular material. It's a constant value for a particular material. That means how much stress is there, and for that, what is the corresponding strain? That ratio will be constant for a material. That constant is only called as That constant is only called as Young's modulus of elasticity, or modulus of elasticity, Young you forget, is equal to was stress upon strain. Are you getting it? What is stress? What is strain? What is the formula of stress? This you will study in the second book of your 11th class, okay? That time again I will teach you this. Stress is nothing but internal force upon area, and strain is nothing but change in length upon original length. Strain is change in length upon original length. And ratio of stress upon strain is called Young's modulus of elasticity, sometimes written as Y. Stress is written as sigma, and strain is written as epsilon. Some people say epsilon, and I say epsilon, okay? So sigma upon epsilon is Young's modulus of elasticity. This formula is very, very important formula. This you will study in second book of your physics of 11th class, okay? First chapter. Clear? Can you note down this one? First, I told you, again I will repeat it. First, I told you about resistance. We resist everything. Whenever there is external force, there is an internal force always exists. That's what I told you first. Second slide, I told you about that internal force because of the structure of the body. It is because of the intermolecular forces which are acting between the molecules of the body. And when you try to stretch one molecule, the other molecule will try to apply equal and opposite force. That kind of force is called as internal force. It is inside the body. It's not outside the body. It's inside the body. And that internal force upon area over which it is acting, that gives rise to stress. The body gets stress. And then I told you about strain. Next slide, I told you about strain. That when there is some force, a particular force is reached, beyond that force, the body will start moving, and the body will change its shape, and there will be a change in length of the body. The change in length upon original length, that is called a strain in the body. That quantity is called strain in the body. And then I told you that the ratio of the stress produced in the body because of the external force and the strain which is produced, this ratio is a constant for a particular material. Like steel, its value will be different. Okay, rubber, its value will be different. Wood, its value will be different. Concrete, its value will be different. Okay, different types of metal, its value will be different. Different types of steel, its value will be different. So every material has got some Young's modulus of elasticity value, constant value, and that value is nothing but stress upon strain. This is the formula for Young's. Young is a scientist, and modulus of elasticity is a constant. Its name given to the constant, which is the ratio of stress upon strain. Okay, is it clear or not clear? So once you have noted this particular slide, last slide which I have noted, remaining slides I will send you in the PDF format also. But you just note this slide especially and raise your hand. Okay. And any doubt also you ask. Okay. Feel free to ask doubts. Okay. We have not even started the question because question is very simple. Question is not that important, but just since there are new terms are coming and to create your interest and to maintain your interest, I'm telling you new things every time. Okay. Nishant, you completed. Okay. So one thing, our discussion last class, one discussion we left at one place when I was telling you the classification of mechanics subject, how the mechanics subject is studied actually. So that I will just complete it now because that was an important thing. And we are going to start mechanics only from the next classes, the first chapter of the mechanics and all. So we should know how mechanics is studied. And last class, I told you the definition of mechanics also. And that the definition was that it is nothing but the study of state of state of rest or motion of the body. In fact, now it all depends on which type of body it is. Okay, these bodies are of various types. Bodies are of various types. It can be, first of all, first classification is very basic classification, that body can be a solid or it can be a fluid. Fluid includes both liquid and gases. Okay, liquid and gas. Basically, the liquid is compressible fluid and gas is incompressible fluid. Okay, sorry, liquid is incompressible. Generally, normally it is incompressible, and gas is a compressible. It can be compressed, but liquids cannot be compressed. Okay, so and solids are also of two types. One is the rigid solid, another is the one is called the rigid solid. Second is nothing but what we call non-rigid or elastic, or you can call it as what is the name given for it? Non-rigid. Let me write non-rigid now, but I just missed the name of that. What is called rigid and non-rigid. Okay, rigid means when we apply force. Rigid means what? When we apply force. When we apply force, the shape of the body or the size of the body, anything will not change. Will not change. Now you will say that how, sir, you can say that some body is a rigid body. See, for example, a table, an iron table may be rigid body for you, because even if you apply the force, you cannot bend it, you cannot twist it, you cannot elongate it, you cannot do anything with it. Okay, you can only throw it also, but you cannot change its shape. But for a bodybuilder or somebody or elephant, that iron table may be a non-rigid body. Okay, it can be a flexible body or a non-rigid body. Its shape will change for that elephant. So rigid and non-rigid all depends on the type of the force you are applying on the body. Okay, if you are applying very high force or large force, then definitely that body will come into the non-rigid category. Okay, so non-rigid body is the body which will change its shape or size on the application of the force. As such, there nobody in this world is rigid. Okay, change its shape and the size on the application of the force. This is the definition of non-rigid body. Okay. Now, this incompressible and compressible, incompressible fluid is like water and compressible gas like air. Okay. Now I'll tell you further classification. So further classification is like when we are come to the rigid and non-rigid. Now further classification, again I'll rewrite it here because I have to continue from here. Rigid and non-rigid. And here I have written incompressible and compressible. So basically, when you talk about rigid, we started with solid. Na? So rigid body studied under classical mechanics. Classical mechanics. Simply mechanics also we can call it a mechanics, classical mechanics. So rigid, in this we don't bother about what shape will change of the change in the shape of the body is not considered here. Okay. Any body, if you take a car, means how car is moving, what is the velocity of the car, how much the car will move. Okay. And suppose the car is at, okay, so all those things, but we never talk about that whether the car will change its shape or not. That we never talk. Even we will apply the force on the car will start moving, or car may be at rest also, but we never think about that whether the car will change its shape or not, or how much change will be there in the shape. That and all we don't talk in classical mechanics. Again, classical mechanics is divided into two parts. One is for the bodies at rest, it is called as statics, and the body which are moving, it is called dynamics. the bodies which are at rest. And when we study those bodies, for example, a child is sitting and he's at rest, even though so many people are applying force on him, maybe you are pushing him and your mother is also pushing him from the other side, your father is pushing him on from the other side, and somebody else is pushing him from all the sides, but still suppose he is at rest, there is an equilibrium. So that kind of how much force everybody should apply so that he remains at rest and he does not move, so he still is rest now, that kind of study is called statics. Or moving with a constant velocity also, that is also coming under statics. Constant velocity, velocity is not changing, that type of study is called statics, that you study in statics. And dynamic subject is basically for the bodies under motion, accelerated motion, bodies under accelerated motion, that is studied under dynamics. Dynamics again divided into two parts, okay, kinetics and kinematics. Kinematics and kinetics. So basically, what is kinetics and kinematics? Kinematics studies, in the kinematics, we just try to find out what is the velocity of the body, what is the acceleration of the body, what is the displacement of the body, all those things, without thinking about the force, without talking about the force. Although force must be acting on the body, but we never use the second law. We don't use force equal to mass into acceleration. We may use V equal to U plus AT, that and all we can use, S equal to UT plus half AT square. But we are not concerned, we are not knowing what kind of forces are acting on the body. Okay, we are just simply calculating, finding out the velocity, acceleration, time, but we never talk about force. Although force may be acting, but in kinetics, we always talk about the what is the end result because of the action of the force on a body. Okay, so that force also is considered when we study kinetics. Okay, so this is just a broad, don't think too much, just I'm telling you overview, I'm telling you. Okay, so you also take it superficially only. When you study really, then you will understand what is the difference. Okay, so this is the classical mechanics. Okay, this part is what, so many books are coming on classical mechanics. If you go to a bookshop and ask for a book on classical mechanics, separate thousand pages books are coming on classical mechanics. That is totally separate subject. Okay, that is a rigid body, that is only for rigid body, this entire thing. Then for non-rigid body, another subject that is called as solid mechanics. Solid mechanics, and another name of this subject is the strength of material. So many names are there for the same subject, that is called strength of materials. Sometimes it is also called as mechanics of solid. All are same only. So this particular, when we study the non-rigid body, we are bothered about what is the change in the shape of the body, change in the shape and the size of the body. Okay, when you apply an external force on the body, when you apply a force on the body, how the body shape will change. Okay, how the body will shape will change. And also here we study that when the body will break, how much force you have to apply that body will break, or how much force a body can sustain without breaking. For example, you are sitting on your chair. If very fat person will sit on your chair, at some point of time the chair will buckle, the chair will break down, right? If an elephant chair sits in your chair, the chair will break down. If some fat person is sitting, the chair may sag, sagging, you know. So that kind of changing in the shape, kind of twisting or elongating or shortening, okay, or shearing. This kind of, okay, sorry, not shear, okay, shearing also, yeah, shearing also. So what I'm telling is change in the shape in the form of twisting. You can twist something, right? If you have a rod, you can twist it, or you can elongate it, or you can compress it. You can do so many things. You can apply force from all the sides, right? So what kind of force you will apply, and what will be the change in the dimension in the body, and how much force that body can sustain, and by what force the body will break, and how much the body will change its shape. All those things are studied in this solid mechanics. Like design of bridge, how the bridge should be designed so that it does not sag too much. The design of your house, how much force will be acting on your house so that the house does not change its shape, or the house should be able to take the strength, it should have strength, it should not break. Okay, any material, if you're designing, and it's if you're considering that particular subject where you want to know what will be the change in the dimension of that body by applying how much force, that is studied in non-rigid, that is called as non-rigid bodies, and that is called as solid mechanics. For this also separate books are coming. When you go into college and all, you will understand. So many books are coming for solid mechanics. Thousand pages books are coming on solid mechanics. It's a totally different subject. Even in your book also, in your 11th class also, classical mechanics is studied in the first book. Okay, the first chapters, that is the motion in one dimension, motion in two dimensions. Okay, all those chapters, laws of okay, motion in one dimension, motion in two dimension, friction, work, energy, all these things basically they fall rotational mechanics, gravitation. These all basically they are a part of classical mechanics. Okay, and the second part of the book you study basically the second part of the book, some chapters which are belonging to the solid mechanics. Okay, in part of the book some chapters belong to the classical mechanics. That is the thing. So 11th class is basically all about mechanics only. Okay, mostly we study mechanics in 11th class. Clear? Then coming to the fluid part. Now I'll talk about the fluid part. So in fluid also I told you there are two types of fluid. One is the liquid, another is gas. Okay. So what will happen to the liquid when you apply the force on the liquid? So that is basically studied under the fluid mechanics. That subject is called as what? Fluid. Again, it has got a definition. The study of the state of rest or motion of the fluid, okay, is called fluid mechanics under the application of some force, right? How the fluid means water or liquid or blood or whatever, how it will behave when you apply force on it. That is a totally new subject, because liquid behaves differently when you apply force and solid behaves differently when you apply force. You understand or not? Have you ever applied force on a liquid? Yes or no? Yes or no? You applied force on a fluid, you are applying or not? When you are taking bathing or playing or something, you are drinking or whatever you are doing, you are always applying some force on the fluid, right? And how the fluid will behave is totally different than solid. If you slap a solid, fine, no problem. The solid will resist. What the solid will do? It will resist. It will not move. Nothing will happen. Okay. But when you slap a fluid, so many things will happen. The fluid will react. Okay, the fluid may fall down or may go away. Okay, so it will not resist. Fluid will not resist. Okay, so all those things are there. So how that all those things I will teach you in the fluid mechanics chapter is there in your book, in the second part of the book. That time I will teach you fluid mechanics. Okay, and again the gases also behave somewhat. This also studied, but gas is basically a compressible fluid and its totally behavior is even further different than fluid. Okay, and that is still, I don't know whether you are studying, you will study, because gas also you will study in kinetic theory of gases. That is also there in your book, kinetic theory of gases, and some things are there about gases separately. Separate chapters are there for gas. And one more thing about gas is basically we are going to study thermodynamics. Another subject, not mechanics. It's a thermodynamics, means it's about thermal things. Okay, but there you study a lot of gases, how the gases heat transfer and all those things you study in that subject, thermodynamics. Okay, so this is broad classification of mechanics. Okay, so what I will repeat it one more time. What is the broad classification of mechanics? I'll just show you all the slides one more time so you can understand. So I told you that basically mechanics is, I'm repeating it. Okay, study of the state of rest or motion of a body is called mechanics. There are two types of body, solid and fluid. Okay, in this world, fluid means liquid or gas. Anything which can flow is called fluid. You know, definition of fluid. Anything which can flow is called fluid. Anything which can flow is called fluid. Okay. So solid and fluid. And solid, you know, so what is it? You that and all you studied in 9th class. What is the difference between solid, liquid, and gas? Solid has got a lot of intermolecular forces of attraction. Liquid has got less intermolecular force of attraction. Gases have least intermolecular force of attraction. Solid do not change their shape. Liquid change their shape. Like that and all you studied. So like that. Okay. Solid as rigid and non-rigid. Okay, two types. Rigid means which do not change their shape under the application of force. Non-rigid means they will change their shape or size when you apply the force. Right? Force, you know now what is force. So then again, the study of the rigid solids, that is called as, I told you, that is called as classical mechanics. In that rigid solids, classical mechanics also divided in two parts: the study of the bodies at rest and study of the body which are under accelerated motion. The bodies under rest, they are studied under the subject of statics, and bodies under motion, that is studied under the subject called dynamics. And statics means, suppose there is I gave you one example. There is a child and so many people are applying force on it. One, your father may be pushing him from the left, and your mother may, sorry, your father and mother, maybe your friend is pushing from the left, another friend is pushing from the right, and somebody is pushing him from the top, but he is not moving at all. He is very rigid child. So basically, he is at rest. So when something is at rest, then you have to find out which force acting from which side and what angle, so that the child remains at rest, how much force I should apply and how much force he should apply. That kind of study is done under statics. Dynamics again divided in two parts. Dynamics is bodies under accelerated motion, that is called dynamics. Again, it divided in two parts: kinematics and kinetics. Kinematics, there you study, there you don't bother about force acting on the body. You just study about velocity, acceleration, displacement, using the simple this thing: V equals to U plus AT, S equal to UT plus half AT square. Those things which you study in ninth class. Okay, that thing. Then kinetics is basically the second law you use. Newton's second law, that how much force you will apply and how much acceleration will happen. When you start linking the applied force and the action on the body, that is called as kinetics. Okay, that also you have studied in laws of motion chapter is kinetics chapter, and motion in one dimension chapter is kinematics chapter. Okay, first chapter, third chapter of your book, that is a kinematics chapter, and laws of motion chapter, that is a kinetics chapter. Okay, now coming under non-rigid body, that are flexible bodies, that bodies are called as, that body, that study is called as solid mechanics. Okay, that study is called as what? Solid mechanics. It's also called as strength of materials. It's also called as mechanics of solid. And there what we do is we find out how much change in the shape will happen by applying how much force, and when that force will be reached such that the body will break. Okay, so basically we find the how much the body can accept the force, and we design the substances according to that. For example, we design an aeroplane. We know that what are the forces which are going to act on the aeroplane. So we don't want the aeroplane to break down or to just wrap apart or split apart. So we will design it accordingly. So that kind of study is very, very important subject is solid mechanics subject. Okay, everything in this world is designed based on solid mechanics subject. So it's a very important. So if you are going to do mechanical engineering, all these things you study in very detail. Okay, if you are going to become a mechanical engineer, you are going to study these topics in too much detail. 11th class. Okay, 11th class is the mechanical engineering class, and 12th class is the electrical engineering class. Okay, 12th, whatever you are going to study, if you are very much interested in going in electrical field, electrical and electronics field, then you have to study 12th more, more depth. You have to go into that. Okay, in 12th also, the first book is basically electrical engineering, second book is electronics engineering. Okay, like that. And 11th class, first book and second book both belongs to a mechanical engineer. Okay, when you go into mechanical engineering, if you studied 11th class properly, you will be very happy in studying mechanical. You are going to go detail in that. Okay, because mechanical engineering still, it means nothing but mechanics only, right? We do mechanics only in mechanical engineering. We study the state of rest or motion of the bodies. The mechanical engineer does that only. What the mechanical engineer does? He does what? He repairs the bike and car, means he studies bikes and cars, automobiles. So everything, whatever you are seeing physically, what you are seeing physically, that is nothing but either under the state of rest or under the motion, right? And then comes the combination, that is electrical and mechanical. You are supplying electrical energy and the body is moving, right? So it involves both electrical energy, electrical engineer also, and mechanical engineer also. Okay. So nowadays the new type of branches of engineering are coming, which involves both electrical and mechanical also. Okay. So if you are a particularly mechanical engineer, means you don't know the electricity part, electrical part, current, resistance, and diodes. Those things come under electrical engineering. Okay. Mechanical engineer will know only this kind of thing, what I'm teaching you. Okay. Solid, liquid, gas, motion, statics, dynamics. Okay. Now coming to the next category. So as I told you, twisting, elongating, these kind of things are studied under solid mechanics. Okay. And then comes your fluid part. Fluids are classified into liquid and gas. Liquid is incompressible, gas is compressible. Incompressible means when you apply force, it will not change its means I'll explain you, okay, what is incompressibility and compressibility. Okay, leave it. But what is liquid and gas? You know the difference between liquid and gas. So liquid is studied under the chapter subject called very deep subject and very big subject, fluid mechanics subject. And that is the study of state of rest or motion of a fluid is called fluid mechanics. Okay. And then gases are compressible fluids and they are studied under we cannot at all study gases like that. Basically, we'll study kinetic theory of gases and some that is true. Okay, I'll teach you. Okay, whenever I teach you, I'll tell you detail about gas. Okay. So these are all the classification of mechanics. This is all the introduction. All these things are there in your book also. Okay, somewhere maybe there. I'm not going through that entire thing, but it will be there somewhere. This kind of introduction of the subject. Okay. There. Basically, I am telling you what are the things you are going to study in 11th class. Okay. Now, which questions you have told me doubt? Sixth question also you told doubt. I think fourth and then sixth. So I will tell you sixth question now. 1 minute. Mahalakshmi has told something. Having doubt in second and sixth question of objective. Okay. Okay, right. I will tell you that one then. Yeah, all of you have to become very sincere. Okay, all of you are already very sincere, and especially I mentioned that Shruti and Mahalakshmi really, whatever I tell them, they do it. Okay, even Nishant, Harini, everybody is doing. But all please follow me. Whatever I am telling you, do it. I am very, very happy. Okay, I'm already very happy with all of you, and you please keep performing. Whatever I tell you, do it. Okay. I told them to do that all these questions example. They really done all the questions and example like that. Everybody has to follow. Okay. So now coming to question number 2, you have doubt in objective 1. So I will tell you question number 2 in objective 1. So all these things no need to note. If you are noted, very good, and not noted some things means I'll share you the slides of the class, so you can also one time you please note it completely in your notebook, okay, and send me. Huh? Okay, if possible, send me. Otherwise, note it properly. Okay. Then question number 2 of objective 1: a physical quantity is measured and the result is expressed as NU. I am reading the question for you. A physical quantity is measured. What are physical quantities? So many physical quantities are there, like mass, length, velocity. All these are physical quantities. Anything which can be touched, and I mean whatever something to be measured, it's quantified. Okay, physical quantity means mass, length, and time. All these are physical quantities. A physical quantity is measured, and the result is expressed as NU, where U is the unit based and N is the numerical value. Means U is the unit and N is the numerical value. Okay. U is the unit used and N is the numerical value. Okay. If the result is expressed in various units, for example, 5 meter. So 5 is N and U is meter. If different units means N value will change. 5 meter is 50 centimeter, right? It is 500 millimeter, right? So obviously that uh, they are giving 4 options for us. First is size. N is directly proportional to size of U. Second option, N is directly proportional to U square. Third option, N is proportional to root over U. And fourth option, N is inversely proportional to U. I don't know how to treat this question because U, they are telling unit used. Okay. Now, suppose you are using a bigger unit. Then N will be smaller. For example, you are using meter, N is smaller. If you are using millimeter, N will also be. So what is called a bigger unit or a smaller unit? I don't know whether you are calling U as a bigger unit. So if U is a bigger unit, then N will be value is small. That means N should be inversely proportional to. I think this is the correct. I think so. Because if you see U is a meter means N is very small, 5. If U is millimeter, is a small unit, N value is very high, 500, right? So I think so, like that, the option like that. But not very sure because question is not very, very clear. Okay. If we are understanding the question in this manner, then N should be inversely proportional to U. Okay. If any answer they are given, I will check. Okay. So what they are telling, second D they are telling, correct? That only they are also telling the same answer. N is inversely proportional to U. If U is a bigger unit, the value of N number will be small. Okay. That is the question number 2 I have taught you. Okay. Now question number 6 you are asking, that is an integration question. I don't know, you don't know the integration as of now. You can leave this question now. Okay. Question number 6. What they are telling, question number 6. Some integration they are given. Leave that question, no problem. When you learn integration, that time you will see that. Okay. Then any other thing other than that? Mahalakshmi told 2 doubts. Other than that, everything you have solved, Mahalakshmi. What about the exercise given in the book back? Have we solved that also? 19 questions. Shruti, I told you 4th question, I will tell again. 4th question or example, which 4th question, Shruti? Can you tell me? Which 4th question you are asking? Fourth example only now. Okay, 4th example now. What they are telling is, they are given the Young's modulus of elasticity, that is 19 into 10 power 10 Newton per meter square. Okay. Express it in dyne per centimeter square. What you can do is, I'll tell you step by step. Okay. Young's modulus value they are given 19 10 raised to 10 Newton per meter square. They are asking us to express in terms of dyne per centimeter square. So that's basically CGS unit. So if you know the Newton to dyne conversion, that you can use directly. Otherwise, Newton is nothing but mass into acceleration. Kg meter per second square upon meter square, right? Mass into acceleration. This is mass, this is acceleration. Like this. So what we can do is kg upon 1 meter will get cancelled. Like that it will happen. And then what you can do is convert into grams. 1000 gram. Convert into centimeter. 100 centimeter. And second is second only, right? So this two will get cancelled. So only thing will come is that 19 into 10 power 10, 10 power 11 it will become. That's all. Gram per centimeter second square. That is only dyne per centimeter square basically. Okay. Okay. If you convert into dyne, means what is dyne actually? 19 into 10 power 11. Dyne is basically gram mass into acceleration, a centimeter per second square per centimeter square. This is per centimeter. This is dyne. So this is the answer, 19 into 10 raised to 11. Or one more method I tell you is that you know that 1 Newton is 10 to the power 5 times. So you can use that also. 19 into 10 power 10 Newton per meter square. So what you can do is, you can write it as 10 raised to 5 dyne upon 10 raised to 2 centimeter whole square, right? So what will happen now? 10 raised to 10, 10 raised to 4 dyne per centimeter square. Now you can understand what is the answer. This will cancel and this will become again 19 10 power 11 dyne per centimeter square. Got it or not? This is the dyne is nothing but SI CGS unit of force. Okay. And 1 Newton is 10 power 5 dyne, that you should know. Okay. So any other doubt other than this also you can ask. Okay. Otherwise, again, I will tell you, you solve all the question, objective 1, objective 2, exercise, everything you try. Which are the questions doubt, mark it, okay, and then we can, because all these questions already we have discussed. So many things we have already discussed. And whichever you have doubt, you just mark it, okay. If all are doubt, all you mark it, no problem, okay. Don't hesitate to mark, then we can discuss, okay. Because these are basic things. It's an introduction to physics only. We are also, today also we are done introduction. We are creating your interest only, okay. Once you get interest now, everything will be perfect, okay. So you should have interest. Physics is very, very interesting, extremely interesting subject. and you should never lose interest in that. Okay, it is not a numerical subject or something like that, or something like mugging up. It is a very, very thoughtful and interesting subject. Okay, and that way only you should study physics with full interest and full doubts. Whatever doubts and anything is coming in your mind, totally you have to think freely. Okay, in physics you have to think naturally in physics, not some method or something like that. Okay, there is not nothing like method, or method is there, but method also by understanding only you should follow that method. Okay, there is no such thing like solutions. With solution you should refer and solve, like that every time you should try and solve. Method you can understand how to solve, but after that you should try yourself. Okay, and think normally, naturally, and solve the questions, because there is now much formulas and all in the physics. Formulas are also very limited, formulas are there, but questions are many, because situations can be physical situations, are so many situations are possible. Okay, so there are so many real life situations where you have to apply the basic formula and solve the question. Okay, mechanics is totally like that. Mechanics does not have much formulas, maybe 10, 15 formulas totally in mechanics, but questions are thousands and thousands of questions are possible. That's why I told you, when you study a book on, when you purchase a book on classical mechanics, you will find only problems there, so many problems. Okay, so problems are more, formulas are less. Okay, so you have to start start getting that habit of solving new problems. Okay, don't get frightened from seeing any new problem. Always try it, naturally try it. Okay, this chapter is very basic chapter. Okay, dimensions and four units, those things are there in this chapter. Unit and dimension, basically that only. So please try all the problems and tell me. Okay, first go through the theory what is given in the book, then you solve the problems. Whatever theory is given, go through it. Meter, second, ampere, Kelvin, mole, candela. Then dimension and all you know very well. Dimension I taught you already, so no need to read dimension. Okay. SI units and CGS units, that and all you know now. Just to go through it one time. Okay. Okay then. Next class we'll discuss. Okay. Bye.